Screen I am putting. Screen share in that?
Sir, starting sir, share got. Start sir.
Anyway, this particular slide we have already seen, and wherein this was actually giving us an idea on what all the different sources through which the actuator was trying to take input. One is actually the control signal. That input is going to give it an idea that when it should start, how much amount of time it should operate, and when it exactly it should stop. Such a kind of information is going to be there through the signal. And after receiving the signal, it needed energy to work on. So because of that, the second source of energy is that altogether both the things are going to produce the motion, and either the motion or the force. Both are interrelated. Anyway, these two tables are actually a sort of a near method to identify the attributes and the features against the attributes that need to be incorporated in a design. So over here, the requirements of a drive system has been identified in the name as a set of attributes, and those attributes were tried to manage by adding certain features. Okay, so this is what has been showed, and any sort of design when you are trying to take up, and that can be listed out like this, and that is going to give us a clear-cut clarity even for the people who are all trying to go through the content being delivered by you. Okay. Anyway, traction and gear ratios were introduced with few words. Traction basically avoids slip. Okay. So the idea is actually friction between the road surface and the wheels. That is actually the traction. Okay. So maybe a vehicle might be, you might be moving on a vehicle smoothly on a flat road, whereas when you try to move the same vehicle on a sort of hill road, that time also it should not slip. Maybe your design criteria should matter to that extent. Maybe at the time of designing that particular vehicle, that should have got designed to that. So based on that only, things are going to be manipulated. Gear ratio, anyway, you know. Okay, anyway, this particular slide is going to give you an idea on the gear ratio. It's going to be a recall. Here A is actually the driver and B is the driven. So since okay, A is being the driver, that is going to be made to rotate with higher speeds. And if you try to see the driven, since that is with higher number of teeth, that is going to rotate with a lower speed. And vice versa, if you, this is the process wherein you are trying to lower the speed. If you really mind to raise the speed of the driven, what has to be done is, let you convert this particular B wheel as a driver and A wheel as the driven. So right now in the image, A is the driver, B is the driven. If this particular process is actually trying to reduce the speed of the output shaft or of the driven shaft. In the other way, if your requirement is actually to raise, what has to be done is B wheel has to be attached to the driver, then A wheel is going to be converted to the driven, and that is how it is going to be. Altogether, the requirement of rather the basic need for going for gear ratio or bringing contact between two gears is actually this. Like you might be aiming at reversing the gear direction, and you might either bothered about either increase to or decrease the speed of rotation, and you might even be transferring the movement from one axis to the other axis. Even that can be understood from here. See, A axis is at some location, B axis is at some location. Rotational movement is being transferred from axis A to axis B. That is how it is. Then to keep the rotation of the two axes synchronized. See, against A being rotated, B is also going to be rotated. When A is rotating, you cannot make B to stop. You have B to keep in idle condition. That is not possible because both the gears are in mating condition. Okay. Say, according to this particular configuration being showed, against 4 revolutions of wheel A, there will be 1 revolution of wheel B. Okay, so that is how their motion is actually synchronized perfectly. If there are 8 revolutions for wheel A, there are going to be 2 revolutions for wheel B. Anyway, the major target that is applicable to this particular situation is, in a gear train, ratio of output torque to the input torque is constant and is equal to the gear ratio. So gear ratio, not only it is trying to give us a what you call a relation between the RPMs of A and B, it is also trying to take the ratios of number of teeth, and moreover with the same gear ratio, even the ratio of input torque to the output torque is also. Okay, so that is how we will get an estimation on the torque, what exactly we are designed to aim at. Then of course, if you want me to say simply regarding the tractive effort, it is nothing but the force required to haul a load. Hauling in the sense it's going to be pulling, okay? It might be pull or push, whatever it is. So that is actually the effort that has been in the form of force. Tractive effort is nothing but a force that is essentially required to haul a load. These two plots also we have seen in the last class, wherein we can recall the gears whatever we are trying to apply when we are trying to move on a car or a bike. We might be moving on a car or we might be moving on a bike. We are trying to speak with respect to the geared vehicle, wherein in the beginning we always start with gear 1. After it has attained momentum, certain momentum, we go to gear 2. Soon after that, it is going to gain some more momentum. Then we go to the gear 3. When we talk about the gear 1, you can see here, the tractive load that is about 7,200 or so in terms of newtons. Means gear 1 can handle such a high torque load. When you consider gear 2, that is going to handle only 4,250 newtons or so. So now in the beginning, for a particular vehicle, I don't know what exactly the type of vehicle being considered for this particular plot. I have gathered this information from some source, net itself. Gear 2, if you want to use it in the beginning, since it is limited to 4,250 only, whereas in the beginning the vehicle demands 7,200 newtons, which is highly impossible for us to go ahead with an engagement of gear 2. Now let us see about the behavior of gear 3. Gear 3 is capable of engaging or taking up a load of tractive load of 2,700 or 800 newtons. Now in place of gear 2, again gear 3, it's not possible for us to handle the situations with respect to that. So these are the major concerns what we are able to exactly understand from this particular plot with respect to the newtons. Okay, so this plot again confuses us. Say variable speed, say vehicle speed, say at 0, it is not possible for us to run with gear 3 or gear 2 because the torque is 7,250. Though it is confusing us, that has because it has been extended up to zero velocity, we are not supposed to consider that at 0. Maybe this is the speed for this particular one. This is the region, or this is the zone up to which gear 1 can be used. And in between, where exactly gear 1 has to be shifted has not been stated in this particular graph. In between to this particular zone, gear 2 might be. And in this particular zone, in between to this particular zone, gear 3 might be. Okay, so that way you are in a comfortable position with this particular graph. We are very much comfortable to understand the importance of gears as well as the role of tractive effort we'll be able to digest in that. Robo drives, when it has been, we have got electric drives, hydraulic drives, and pneumatic drives. electric drives and pneumatic drives, when you try to consider, you can see here both hydraulic and pneumatic have got two valves, maybe two openings. One is for inlet and another one is for outlet. Through them, one pipe, inlet pipe will be there, one more pipe, outlet pipe will be there, and that is how they have been interconnected. And for electric drives, all such sets of requirements are not there. Why? Because it is going to take the power input. You can see, if you closely observe, the right side of that particular motor, electric drive, is actually having cables. So it requires only power supply and it doesn't require any piping. All such sets of requirements are not there. Okay, so directly if you give the power supply, that will go on activating that particular activator or drive system. Okay, same information, I think it has been re-represented over here. Okay, so maybe in the beginning when it has been recalled many times, that will become a sort of, it will reach you to some extent, into your memory. Sometimes we might not so attentive when a particular slide is going on. So that time it will be helpful, it will be helping you if you really go on getting it repeated again and again. Anyway, actuators drive the robotic arm. That is what the basic purpose being served by an actuator. There are three main types of actuators which we have seen earlier in this slide, earlier slide also. In general, this is not concretely being locked. Hydraulic and pneumatic actuators are being used for linear actuation purposes, say for prismatic joints. And electric motors are normally being used for in order to produce rotation. They are not concretely locked with that particular situation, because with the introduction of KOM concepts, kinematics of machinery concepts, if there is a linear motion, we can devise a mechanism to convert that into rotary. If there is a rotary mechanism, that can be devised and connected through certain links, and that can be converted to reciprocatory motion. That is a secondary aspect. But these are all the zones for which they have been referred to use them. So that is what they have tried to. Underlying principle is all known to you. Pascal's law. We know the Pascal's principle. Okay. So if a pressure has been exerted at some end, at the other end, that pressure is going to be transported through the fluid. So here the fluid could be liquid or it could even be some gas. So anyway, in hydraulic actuator, the treatment is being limited to, our assumption is limited to only for the usage of liquid, and that particular liquid is actually hydraulic oil. That liquid is actually hydraulic oil. Okay, so what are all its characters, we will see depending upon the time, and some content have been collected on those grounds also. We will see when the situation demands to that particular, we will rise to that level. There is no problem in it. And we will see in the next slides how exactly this principle is working is also. So this system, okay, the work fluid can mean both gas or liquid, that is for sure. The system is recommended to use when large amount of forces are required. So this you can imagine, heavy vehicles, say like heavy earth digging vehicles, okay, bulldozers or whatever it is, if you try to consider, even the tractor when you try to refer, they are all trying to take the support of these hydraulic actuators. Tractor, when you want to lift the trailer, what they try to do is it appears as if a gear have been engaged and disengaged. One lever they try to apply, then they accelerate. That accelerator will activate the hydraulic pump, and that pressurizes the hydraulic fluid that is going to contribute towards the trailer to rise up. That is how it is actually happening over there. Okay. Anyway, hydraulic transmission of energy and control is actually being done with the support of liquid, and that is the liquid being referred as working medium. In your refrigerators and air conditioners, we all know the working medium is actually the refrigerant. say R22, R12, 143A is actually the new one. It's not new. It has been put in use for the past, in the recent past years, because it is actually eco-friendly. The other things, R12 and R22, R12 was totally banned. R22 is also getting banned, or it would have got banned. It is actually not environment friendly. Okay, so a fluid which is basically delivering its duties is being referred as working fluid. It uses the hydraulic pump to convert mechanical energy to raise the liquid pressure. It also takes the support of control valves, hydraulic cylinder and pipes, and the reciprocating motion and all. I don't have to tell you. Once the word pump has come, normally there will be a cylinder and there are going to be valves, there is going to be a piston. Once you have a cylinder and piston arrangement, you need to have inlet valve and outlet valve. Inlet valve is to bring the fluid, collect the fluid between the cylinder valves and the piston. Soon after that has been trapped, inlet valve is going to be closed and the piston is going to rise, is going to be moved forward or close to the other end, so that fluid is going to be pressurized. Once the fluid has been pressurized, outlet valve is going to be opened, then that's going to be delivered. Okay, so once you imagine that there is a pump, that too there is a reciprocatory pump, there are going to be valves. So valves, in the sense, here meaning of control valve is different. This control valve is going to control the opening and closing of that valve, through which the hydraulic fluid is going to enter into the cylinder. Okay, so anyway, that is how it is. The working medium is liquid, that is actually hydraulic fluid. Its function is similar to that of a belt, chain and gear. So this particular word is actually a bit hard to digest. This is being fluid, those are all being mechanical elements. We can see them, we can touch them, and we are able to see them physically. Whereas here the fluid we cannot see. We cannot see that the pressure has raised or something, but we can sense its pressure with the support of some pressure sensing devices. It is something like, if you try to consider a motor and a pulley to be driven, they can be connected through pulley. Means the motion is getting transported from the motor to the pulley through the belt. Belt is the device that is trying to transport the motion from the motor pulley, rather motor shaft, to the pulley. Maybe that pulley might be pertaining to the floor mill shaft or something like that. Maybe conveyor system, it could be something like that. Same is the process that is happening with the chain. Say your two-wheeler you try to take, engine is developing power at one end, your rear wheel is actually being connected through chain. So the motion is actually being transported from engine to the rear wheel. Gear drive system is also on the same notes. Engine, no doubt engine to the gear shaft and then to the gear wheels. Through the gear wheels, the torque is getting controlled. Then the RPM is going to be manipulated. Such a manipulated RPM only you are trying to transport to the rear wheel. So that is how in all these three situations, we talk about torque and the motion. All those things are possible even with the medium of liquid through hydraulic. Okay. Anyway, these are all the commonly listed parts in one particular type of hydraulic actuator. Say piston. Let me skip the second point. Let us go to the third point. Single and double acting cylinder, hydraulic valve, then hydraulic accumulator. See, it is something like this. Hydraulic valve is the one what is going to be controlled through the controlling valve. Okay, your controlling mechanism is going to control the hydraulic valve. That is going to assures that the fluid is going to, has to be admitted into the cylinder, or it has to leave the fluid. It has to make the fluid to come out of the cylinder. That control is going to be done. Then coming to the single acting and double acting, in your IC engines, in your IC engines, all processes are happening on one side of the piston only. Okay. Whereas in this particular, that kind of situation is going to be referred as single acting. Okay. So means in this case, pressurized fluid is going to be admitted. Say, let me take some abstraction. Say you have got some cylinder in space. This is the piston. Onto this particular piston, you have got left side and right side. Onto the left side, if you admit the pressurized fluid, pressurized hydraulic fuel, if you admit only onto the left side, such a sort of system is going to be referred as single acting cylinder. In a double acting, say if you admit high pressure fluid over here, this piston is going to be moved that side. In order to bring to this side, what we do is we admit the pressurized fluid on this side also. Since we are trying to admit the fluid onto the right side also, this is going to be double acting. Okay. So in the case of single acting means when you apply, when you admit the pressurized fluid over here, piston moves on this direction. That time what they try to do is they try to accommodate a piston which will be compressed. Okay. Now when the piston moves to this side, the spring which was available earlier, that is going to be compressed. Then when this inlet valve was closed and outlet valve was open, that time the pressurized fluid what was here, that is going to be permitted to leave the chamber. Then the pressure on this side is going to be more, pressure on this side is going to be less. Then the spring pushes this piston to move towards left side. In such sorts of instances, this particular second item is going to be there, spring return piston. Okay. So anyway, these are all some of the components that are all required, or various parts that are all required in a hydraulic actuator. Now pertaining to that spring return, this is actually a sketch. And see here, you have got a control valve here. This particular control valve makes this particular fluid, it has not been showed properly here. Because of that, we may not understand straight away. So it permits this particular pressurized fluid to enter through this, and again it makes that particular fluid to come out. See here, hydraulic supply and return line. So that pressurized fluid is going to be supplied through this, as well as used fluid is again will be permitted to leave through that, and that is going to be controlled through this particular control valve. You can see clearly here, when pressurized fluid has been supplied here, piston moves up. When the piston moves up, spring is going to be compressed. Okay. Then soon after that has been expanded, soon the compressed fluid has been expanded, then this particular fluid is not going to have any other pressure. Then the control valve releases the fluid. Then what happens? This fluid will come out. Once this comes out, on this side pressure is more, here pressure is less. Then that spring pushes the piston down. Now in the next slide, you can see how exactly it is working with an animation. You can see this. This is your control valve. That way you can imagine. This is the zone wherein, in one instance, see, when these two are in short, fluid enters here and then it enters through this. Once it has entered through this, that time only this piston is moving this way, away towards right side. Soon after this piston has moved towards right side, then these two passages are going to be shorted. Then the pressure which was used for expansion is no more having excess pressure, that will be pushed out to the chamber wherein this particular fluid is going to be preserved. And once again it is going to be pressurized and again supplied. Now when the pressure on this side has been lowered because of shortening this and the opening outlet valve, that time the spring pressure is more, and that is going to push this side. Okay. So this end you can assume that there is actually end effector or something. That way you can visualize this. Now this particular image is trying to give you a sort of animated image wherein for an applied small pressure we will be able to make even the trucks to be lifted. It is quite possible. And of course, the principle behind this has been showed here. Here actually greater volume, lesser area, but more distance this particular piston is traveling. This red color is trying to indicate the volume got displaced. And this red color is actually trying to show the volume that has got displaced. Both the volumes are one and the same. Okay, here more displacement was there and here less displacement was there. Here force multiplied by area, rather pressure divided by area is the force. Even here the same. So that is how the force is actually getting balanced. Same amount of force is actually getting transported through the fluid from here to here. So the game they are trying to play with the area of opening. Here lesser area that has been accommodated in the beginning. Here more area have been accommodated. Based on that, the quantity of fluid that has got displaced is going to be varied, but the force that is going to be operated is going to be the same. That's what you should understand from that particular slide. Then coming to this, these are all the requirements of your hydraulic system to function properly. Power source, no doubt it is required. Actuating elements, all components which are all being joined together, okay, which is trying to pressurize the liquid as well. That pressurized thing is going to be sent through the pipes to the actuator to the desired location. Normally, that actuator is going to be housed at the joint of a particular robot. So the pressurizer, rather the pressure being raised and all that is going to be done at different location. Maybe tomorrow, what I will try to do is I will try to collect tomorrow morning 8:30 is the class you are having. I may not be able to show you those images. I will try to show you to the possible extent in the nearest possible class. If not tomorrow, day after tomorrow, I will show you. There is no problem. All those things are going to be referred as each and every part of it associated to that particular hydraulic system of actuation is referred under this actuating element. Control units, what all the aspects need to be controlled, like valve, at what time it has to be open, at what time it has to be closed, how much amount of what is exactly the degrees of rotation. All those informations are going to be controlled through this. Auxiliary elements for any device that will be requiring, like pressure measurement, in order to know the functioning of it. Okay, working medium, obviously hydraulic fluid over here. Now let us see this. This particular hydraulic actuator is actually giving us on the on them. Are you able to see this? Maybe P. Madhun can respond. He mute his mic and speak.
Sir, కనబడుతుంది sir.
Are you able to see this particular slide? P. Midhun may unmute and speak.
కనపడుతుంది సార్.
Midhun
సార్
may unmute
సార్
సార్
కనబడుతుంది సార్.
and speak. It appears he is very busy. KV Shanmukha. Okay.
సార్ చెప్పండి సార్. కనపడుతుంది సార్ అది.
Now you can see this.
సార్
You can see
కనపడుతుంది సార్.
this
కనపడుతుంది
particular
సార్.
wall, and you can see the wall. Actually, fluid is actually getting pumped from here. It is trying to get pumped from here. So this particular slider is actually getting control. This is trying to control it. It is trying to control it. And how it is controlling, you can see a dark blue line is actually the portion which has been shorted. So these is actually the reservoir. From here it has been pumped, pressure has been raised into this particular portion of piston. Right, so that pushes the piston towards this. Amma, చెప్పండి.
సార్
My
ప్రెజెంటేషన్
voice has gone.
ప్రెజెంటేషన్ ఆగిపోయింది సార్. ప్రెజెంటేషన్ ఆగిపోయింది సార్.
Problems వస్తూ ఉంటాయి. Hello.
సార్ ప్రెజెంటేషన్ ఆగిపోయింది సార్.
వినపడుతుందా? నా వాయిస్ వినపడుతుందా?
సార్ మీ వాయిస్ వినపడుతుంది సార్. ప్రెజెంటేషన్
Sorry,
ఆగిపోయింది సార్.
అన్నది.
ప్రెజెంటేషన్ ఆగిపోయింది సార్.
ఓకే ఓకే చూస్తున్నా, ట్రై చేస్తున్నా.
ఓకే సార్. ఓకే సార్.
From my side I am trying.
సార్ మీ మైక్ మ్యూట్ లో ఉంది సార్.
హలో, చెప్పాయా? అవునా, సరే అయితే ఓకే. అమ్మా అలాగే అలాగే ఓకే. I hope this this is
సార్ వాయిస్ బ్రేక్ అవుతుంది సార్.
for you and am I audible?
సార్ ఆడిబుల్ సార్, వాయిస్ బ్రేక్ అవుతుంది.
Okay. So now dark blue is actually indicating that is the zone wherein the high pressure fluid has been admitted to, and that is going to make okay, that's networking problem. This is okay. Clear, I believe. Okay. So the high pressure fluid will be, and once that has been shown, go right now. Okay. Okay. So dark color fluid content so light side is actually low pressure line. That thing is actually, I'll stop my device. It was good. Seems I am audible more now. Dark blue side is actually high pressure zone. Light blue is actually low pressure zone. When dark blue color is coming, that time piston will be moved from that side to the other side. Alternately, the dark blue color is actually coming onto the other side of the piston, and light blue color is actually coming onto the other side of this side of the piston. That time, whichever the side dark blue is there, from that side to the other side, low pressure side, piston is actually getting